Welcome to the lecture online, and today we are going to be looking at the angle properties of a circle. In our previous videos, we have discussed more about circles, and today we're going to look at how angles are related to the circle. So before we just get into all these circles that you can see here, let us first go through the basics that you should have before you get to understand all about all these circles that you can see on the board. The first basic that you should know is that angles in a triangle are supplementary. Supplementary means they must add all the sum of the three angles in a triangle must add up to 180 degrees. What about angles at a point? Angles at a point must all of them add to 360 degrees. So if you sum all the angles at a point like this one, they must all add up to 360 degrees. That means the sum of angles must add up to 360 degrees for angles at a point. What about the angles in a straight line? So in a straight line, the angles in a straight line are also supplementary. It means therefore they must add up to 180 degrees. So those are the basics that you should at least have before we start the series of angle properties of a circle. So let's start with the first one. So the first one, as you can see it, this is a chord AB with in a circle with center O. And of course, you can see this chord subtends an angle to the circumference, and the same chord subtends another angle to the circumference. So what do we know about that? So that means if this angle is x, it means the other angle will also be x. So that means we're going to conclude that a chord subtends equal angles to the circumference, and therefore x degrees should be equal to x degrees. Now, in the second case, we have a chord AB that subtends an angle to the circumference. That angle is x degrees. And if the same chord subtends an angle to the center, then that angle is going to be twice as much as the angle subtended to the circumference. And therefore it means x degrees is equals to 2x. Now, in the next case, we are having a diameter, as you notice. This is a circle with center O, and we have a diameter. And that diameter subtends an angle to the circumference. So what happens when a diameter subtends an angle to the circumference? The angle subtended to the circumference by a diameter is going to be a right angle, and that is 90 degrees. So if this is 90 degrees, subtended by the diameter is also going to be 90 degrees, which is also equal to x. That means x equals to x degrees. In the fourth case, we are having a diagram. This diagram is a quadrilateral, and of course we call it a cyclic quadrilateral, because it touches the circle at 4 points. All the 4 points touch the circumference of the circle. So what do we know about that? Now, the opposite angles, for example, x and y, are supplementary. It means x and y degrees must add up to 180 degrees. And what it means, if x and y are opposite, it means p and q 180 degrees. So this property is known as cyclic quadrilateral. In the fifth case, we have a circle with a tangent. Of course, in our previous videos, we have explained more about tangents, and now you know what they mean. So this is a tangent, and from the tangent point, we have a chord that originates from the tangent point. So we have chord AB that originates from a tangent point, and that chord subtends an angle to the circumference. So what will be the relationship between the angle formed between the tangent and the chord? So if that angle is x degrees, it means therefore the angle subtended by the chord that originates from the tangent is also going to be equal and that property we call it alternate segment. Because this is a segment and on the other side we have another segment. So any angle formed in the alternate segment is going to be equal to the angle formed in the first segment. Also, we have another case where we have a tangent and a center O with some radius OB. So what do we know about when a tangent meets a radius? When a tangent meets a radius, they form a right angle. It means they are going to be perpendicular. So the angle formed between a radius and a tangent is going to be exactly 90 degrees. So this is a very important property if you really want to be able to solve such kind of problems. So lastly, we have two chords. Let me name them AB and another one CD. So those two chords are equal. As you can see, I've indicated that they are equal. And this is what we know about equal chords. Equal chords subtend equal angles. So it means if AB subtends x degrees, CD is also going to subtend x degrees to the circumference. So that's all about the angle properties of a circle. We have so many of them. And in our next video, we are going to do an example involving all these angle properties of a circle and be able to solve them properly. So see you in the next video. Thank you.